Dear students, welcome to research workshop number 3 with the topic of data handling. So in this workshop we will deal with some example survey data, which is survey data from a course at Maastricht University from 294 students in a marketing course that we collected. In this course we asked students at the beginning of the course what their impression of the course will be. This is a variable we called rating pre. We measure that on a scale from 1 to 5, and as you can see on the slide, this is interval data. We then ask students the same question in week number 2, again on the same scale, and we ask them to indicate their impression of the course. Then the third variable that you see on the slide is that we showed students 2 different types of grading schemes, and we did that by having a randomizer implemented in Qualtrics, where 50% of the students randomly got the grading scheme A assigned, and the other 50% of the students randomly got the grading scheme B assigned. As you can see, it is 2 different groups, so we have nominal data. Then we asked students in what kind of student team they were in. So within the tutorials, they also had 3 different teams, and the teams were called A, B, and C. Therefore, we also have nominal data. Then we asked students in a question how much they could relate to the company assignment that they were given in the course. Again, rated on a scale from 1 to 5, therefore interval data. Then we asked students to indicate the number of team meetings that they had outside of the tutorial. So an open-ended questions where students could enter the number of team meetings from 1 to 3, 4, 5, 6, 7, 8, 9, 10, and so forth. So we have ratio data here. Then we asked students whether they intended to do interviews on a yes or no question for the company assignment that they got. And last but not least, the 2 variables that you see at the very end can be classified as demographic variables. Here we asked students about their student status, so whether they were IB students or exchange students or some other type of students from another university, or whether they were guest students following the course. And we also asked them about their gender. Now in the following video, you will hear my colleague actually explaining the dataset to you.
If we then look at the survey in Qualtrics, as you can see here, you see that you can see the questions implemented as I just described. For instance, here the first impression versus the rating after week 2 on the same scale from terrible to excellent. You can see the randomized grading, as well as the question as how fair they perceive this grading. And then keep in mind, participants were randomly, or students were randomly shown either scheme A or scheme B. And you can see here the weighing of the grading components are slightly different. And further in the survey, you can also see the other questions that I just described. Now assume, when you've collected the data, or in this case the data is already available, to download that data you go to Data and Analysis, and Qualtrics generates a preview of this data. And when you then go to Export Data, you can see that conveniently Qualtrics allows you to download the data as an SPSS file directly. It's important that you tick download all fields, and if you've included a randomizer in your survey, it's crucial that you also tick more options and then tick the box here where it says export viewing order for randomized surveys. This is very important because if you tick this, Qualtrics will include, and we'll see this in SPSS in a minute, will include variables showing you which, in this case, grading scheme that was randomized did the participants see. So that's very important that you do that. When you then click on download, you can see here, it'll take a moment, but the file is downloaded. I've already prepared it in a different window here, so I'm not going to open it right now. One final note about the survey in Qualtrics is note that here for the questions, I've already provided variable labels such as rating before the course and rating in week 2. I've also labeled scheme A, scheme B. If you do this in Qualtrics already, that saves you a lot of work in SPSS later on. because it'll just import these variable names. If you don't do this, it'll just number them from Q question 1 to all the way question 20 or so. So that really saves you some work later on. If we now go to the SPSS file, so we've downloaded the SPSS file, clicked on it, opened it automatically in SPSS. This is what you see first. And the first thing I'd like to draw your attention to is the two buttons on the bottom where you have the so-called data view that we're in right now, but also the variable view. And these are the two kind of main windows in SPSS. And I'll first go to the variable view, which offers you a very convenient overview of all the variables from the Qualtrics survey. So you can recognize immediately a couple of them here in the column with the variable names, where, as I just showed previously, if you enter the variable names in Qualtrics, SPSS will just take them. And you can see here we have the rating pre and the rating after week 2. You can also see that Qualtrics has added a number of variables that it collects automatically in the background, so to say, such as the user language, even things such as the IP address, and for instance, the start and end date. To make things a bit simple, I'm going to just keep the start and end date here, and I'm going to take out a couple of these, which you may want to retain these for your survey, for instance, to get more insights, but for the purpose of this video and to simplify things, I will just click here on clear, which is delete in SPSS, to take these out. If we then switch to the data view, you see that this is simplified to some extent by removing the variables. I can see here when a participant started the survey, and I can see when they ended the survey, which sometimes may be interesting to see. In this case, we're not going to pay very close attention to it. More importantly, we can see the different variables here. And the way the data is presented here is that you see the variables in the columns, and each row represents one response by a student in this case, right? So number 1 here would be one student, and who indicated, for instance, that their first impression of the course was a 2 on the 1 to 5 scale, and that seems to have improved after week 2 to a 4 on the scale. You can also see which team they are in, that they've had 5 meetings with their team, and that they are, and most likely, I would need to check what the coding of the gender variable is, and we'll get to that in a second, but we can immediately see what the respondent ticked in the survey. And this is then the data for the second respondent, the third, fourth, fifth, and so on. That's the way you need to consider the data here. Going back to the variable view, because I was just talking about the coding of gender, what's very important that you do before you start analyzing the data in any way is that you make sure that the variables are labeled properly in a way that you can recognize them. Something to note is that SPSS doesn't allow you to leave spaces, so you can't do rating space pre, but you can kind of create spaces by using the underscore. Most of the other data is automatically imported from Qualtrics. So you can see here in the label box, it actually includes the question, which is quite helpful to remind yourself of what the question was about. You could also simplify this if you would like a simpler label, such as here, simply first impression. And then here, week 2 impression, if that's more convenient. That is completely up to you. What you should definitely look into are the values. And this is what I referred to earlier with gender, where it includes 1s and 2s. And here, Qualtrics automatically imports this. If it doesn't, you can also manually enter it. And you see here that a 1 represents males and a 2 represents females. The very important thing to do here, because this is not always automatically offered from or imported from Qualtrics, is that you assign the appropriate scaling, or what's called measure here. And in this case, we'll go through this and recall that rating pre was a 1 to 5 scale. And you can see here, if I click on this, that SPSS distinguishes between nominal, ordinal, and so-called scale data. And scale data includes both interval and ratio data. In this case, rating, the first impression rating is measured on a scale, so that's the right type of measure we have here. Rating week 2 was also on a scale, so that's appropriate. The question about whether the grading scheme that they saw, either A or B, was fair is also on a scale. The team, however, we can see here is A, B, or C, which clearly is a nominal variable, and thus we should change this here. There was a question about how they relate to the MRP assignment, also on a scale. The number of meetings was simply enter a number ratio, and because SPSS doesn't distinguish between scale, interval and ratio data, scale is fine here. Interviews was as you can see here, a yes or no question. So this should be nominal as well. Student status, as you can see here, is also a nominal variable. Gender is a nominal variable. And these here are the 2 grading schemes. And we'll take a closer look at this later, but do recall this is simply a variable whether a participant saw a grading scheme A or B. And this clearly is also simply nominal data. So once we've entered that, we are very much good to go with starting to explore the data. And something that you may want to do while exploring the data, so if we click on the data tab here, is to, for instance, sort cases. So you could indicate that, for instance, you would like to sort the cases by gender, hit OK, and you see what's happening now. SPSS opens a so-called output file where it saves all the actions you did, and it'll present you with, for instance, test results or any figures you generate. If we go back to the file and then the data view, we can see here that all the data is now sorted by gender. So we have all the ones, as I recall, males listed first, and then the females. The other thing you may want to do is to select only certain cases. Because, say, for instance, in a certain analysis, you're only interested in analyzing the data from, for instance, members of one of the teams, right? You have a feeling, for instance, that in one of the teams, something is, students may have a different attitude than others, and you just want to have a look at these. So you could select certain cases, then click on if a condition is satisfied, and then enter here very much in a formal formula type of way. You could indicate if the team is equal to 1, which in this case is team A, then you want to select these cases. And if you hit continue and OK, what will happen in the data view is you see SPSS has temporarily excluded all student responses that are not in team A, right? So this is a response by someone who's in team C or 3 here in the data, and it's temporarily, not permanently, excluded. And you can simply reset that by going to select cases and simply ticking all cases again. And you see here again that all your actions in terms of the syntax are saved. Another thing you could do, which is similar to selecting cases, is going to data and splitting the file. Say you wanted to run the same analysis, but within 3 different teams. What you could do here is, again, enter that you want to split the data based on the teams. We just quickly need to find the team variable. Hit compare groups, or better, organize output by groups, and enter the team variable here. If you then press OK, all the following analysis that you run will be conducted per team. Yeah, note that this is not a statistical test. This is just if you are exploring the data. And I'm not going to do it now, but if you do it and want to reset it, you again go to this option and then tick Analyze all cases, do not create groups. The first step in data analysis typically involves looking at some descriptives of the data that you've collected. And we do that by clicking on Analyze, Descriptives, and then we can distinguish between, we could say, quantitative descriptors for variables that are measured on a scale, meaning interval or ratio, or we could look at frequencies, which is appropriate for variables measured on a nominal or ordinal scale. And I'll go ahead and do that. Start with frequencies. And what we do here is see how many students, for instance, are assigned to which team. And we could move that variable here. Make sure that we display a frequency table, and we're getting a bit ahead of ourselves, but we could also ask for certain charts, but we'll get into that later. So if I hit OK, you can see here that SPSS gives me a so-called frequency table in which I can see how many students who answered the survey were in team A, B, or C, and it also tells me the percentage. We see it's a fairly even split here. So that's quite useful when you want to get a first feel for your data. If we then want to explore more quantitative variables, such as the scales that we measured, then we'd go to Analyze, Descriptives, Statistics, and Descriptives. And here we could enter, for instance, could take a look at the first impression scale. We move that over here. We could go to options and then ask for different statistics, but we'll just keep the standard here. Hit OK. And we can see here that in the entire sample, all 249 participants answered this or responded to the scale. The minimum value was 1, 5. The average score was a 3.5, and the standard deviation around that mean was 0.865. Now that's very useful to do as a first step, to look a bit into the descriptives of all your variables. Another, or a more visual way of doing that, is to create different graphs to represent the variables. And you can do that by clicking on Graphs and then selecting the so-called Chart Builder. And this is a very convenient interface which allows you here in the bottom to choose different types of charts. You can then drag and drop them in the window above here. And then here you can also see the variables that you have, and those you can then kind of drag and drop into the chart. So if we, for instance, were interested in creating a pie chart to see or to visualize what we previously saw, namely how many, what's the split of students in the teams, then we could look for the team variable, drag and drop that into the slice by, completely ignore what preview it shows here. As you can see, the chart preview uses example data, so this won't be the data that, so this won't show your actual data. Hit OK, and you can see here that SPSS has generated a pie chart where you can see how many students are in team A, B, and C, or the split of this. If you double click, it opens an editor, and if you click here, you can also add data labels, either percentages, or if you go to the number format, apologies, here, by adding the count. And there you then have both the percentage and the actual number. And then you can just click and it'll update the figure accordingly. Another type of graph we may want to create is a so-called histogram, which shows you the distribution of respondents' ratings on a certain, for instance, scale, to see where, to kind of visualize what did most respondents answer on a scale. For instance, we could look at we could open the chart builder, then select the histogram. We'll take out the team variable again, and what we could be interested in is seeing how did respondents answer to the question about how they feel that they can personally relate to the MRP assignment they are working on. We can then drag and drop that here. And what's typically interesting is also in the options here to ask for the normal curve. If we then hit OK, you can see that the histogram, which shows us the responses on the scale, a 1, 2, 3 to 5, and how often that was ticked. So we see that in this case, close to 100 respondents, for instance, ticked a 4 on the scale, indicating that they can fairly well identify or relate to the company. We see that the data distribution here does not seem to be very normally distributed, seems to be skewed to some extent, which may have some implications for the assumptions of the statistical tests later on. So it's good to take a look at this early, but also to just understand what's going on in the data. We see, for instance, that there's a large amount of participants who can fairly well relate, not a lot who find it extremely easy to relate, and there's also a bit of a grouping here towards the lower end, which may actually suggest perhaps the ability to relate to the MRP assignment could be dependent on the type of MRP assignment that participants have. Assume we want to now explore that in some greater detail. We could obviously run a statistical test on this, but just to get a first feeling, we could also create a different graph to do so. And what we could do is create a bar chart. If we go to bar here, add this here. We could now move the extent to which participants can relate to the y-axis, the dependent, and then on the x-axis we could add the team that they are in. And then we could ask for this figure. And we see indeed there are some differences across the teams in terms of how they can relate to the assignment. And it seems that students in team B can relate best, followed by team A and then team C. Now we can't really draw any conclusions about statistical significance about this. For that we'd need to run a test, but it offers a good understanding of the data already. The last type of figure we may want to create is a so-called scatter plot to visualize the potential relation between two metrics, so interval or ratio variables. And we can also create that in the chart builder by selecting the scatter dot. Just going to close the options here. Adding the simple scatter in here, removing the variables for now. And what we could explore, for instance, is whether there's a relation between what we just took a look at, how well students can relate to the assignment, which I'll put on the x-axis, and their overall rating of the course after week 2. We could assume that if students can better relate to their MRP assignment, there may be a chance that they have a more positive impression about the course after the second week. So I'll add this here, and also be sure to add a fit line to indicate a trend. If I then hit OK, we can see the simple scatter plot here. Because it's both measured on very neat 1 to 5 scales, it looks a bit like a grid. in this sense. And we can see there seems to be a slight positive trend, meaning that the better students can relate to the assignment, the more positive they find the course. But it doesn't seem to, we don't see a very clear relation here, right? We can see that there's actually no students who felt that they cannot relate and found the course extremely positive. We can see that, however, students who found the course not very positive, there are no responses there amongst those who can relate. So there's some evidence, but it's perhaps not very strong evidence, we would say. Another important data exploration tool is the transforming of variables, which might be needed in order to perform certain tests. And there are two types of data transformation or variable transformation that I'd like to briefly show. The first is the example of creating a new variable by recoding existing variables. And I'm just going to quickly delete this here. And an example of that would be, for instance, consider I would like to simplify the information about how many team meetings students had. For instance, we see here that some students didn't have any meetings, some even had 5, and assume that, for instance, the teaching team has a feeling that in the first 2 weeks, students should have had at least 3 meetings, which is an indicator of that they're really working on the project. And we'd like to simplify the information a bit to categorize the responses here simply according to, did a participant within their team do less or more than 3 meetings in the first week? And the way to do this is by going to transform and then selecting recode into different variables. And if we do that, the new window here opens, and what we'll do here is we'll take the variable, how many meetings did you have? And you see already here that the interface is asking you to specify into which new output variable are you going to transform this. And we're going to call that variable, quite straightforward, enough meetings. And I'm also going to apply the same label to that. And then very important, hit change. So the program knows we're going to do something with the information from the meetings variable to create a new variable called enough meetings. We'll then hit all the new values to specify for which values of meetings which new value should that assume in the new variable. And I mentioned before that what we want to do is create a simple binary or nominal variable about not enough meetings or enough meetings. And let's assume we take 3 as a cutoff point. What I would do is I would select range lowest through value, meaning all values from the lowest up to a certain and including a certain value can be grouped into one. And remember that I said it should be 3 or more meetings. So I'll start with the other way around, saying that anything up to and including 2 is not enough. And in this case, I would assign a new value of a 0 to this and then hit add. So what's going to happen now in this new variable is that any participant who had 2 or less meetings will receive a 0 in the new variable. And the other way around, range value through highest would be anyone who had 3 or more meetings will receive a 1. The 0 and 1 in this case is arbitrary. We could also do 1 and 2. It's just important that you note down how you code this so you can later on that you know which number represents which meaning, not enough or enough. We then hit continue and hit OK. And if we then go to our data, we can see here that a new variable has been created, which is called enough meetings. And if I drag and drop that variable next to the original meetings variable, you can immediately see that the first respondent had 5 meetings, which would categorize as enough meetings. A few rows further down, someone had 2 or even 0 meetings, which in this case receives a value of 0, meaning not enough values, not enough meetings, of course. To also make sure that in any analysis, this 0 and 1 is included in the analysis, we would need to go to the variable view, find our new variable enough meetings, and also type in these values that we just specified, meaning a value of 0 is something like not enough meetings, and the value of 1 could be something like yes, enough meetings. Hit OK, and then in all analysis you would no longer see the 0 and 1, but the no and yes, which helps to interpret the data. The other type of data or variable transformation that I would like to explain is the option to transform one variable or the values within one variable without creating a new variable. And somewhere where that is very important is when you have included, for instance, a randomizer. You can also recode variables within each if, for instance, within themselves, if, for instance, with gender, you had just an M or an F as text in there and you wanted to recode that into 1 and 2. You can also apply the procedure that I'll show there now, but I'd like to particularly emphasize the how to process data from the randomizer. And the randomizer, recall that participants saw either a grading scheme A or a grading scheme B. That is captured in these 2 variables. And inconveniently, Qualtrics or SPSS has created 2 separate variables. But what we actually want is one variable telling us whether a participant saw A or B. And the way I'm going to tackle this is by focusing on taking grading scheme A as a basis. And what I'll then do is go to transform and now select recode into same variables. And what I'll do is I'll enter the scheme A variable and go to old and new values. And if we take a careful look at the data here, we can see the way grading scheme A and B is coded is that if a participant saw grading scheme A, they have a 1 in this column here. If they didn't see grading scheme A, there's a missing value, and we can see that, well, instead they saw grading scheme B. And what I want to do is merge this data into one. You could kind of manually do this, but especially with large data sets, that's quite tedious. That's why we'll recode grading scheme 1. And what we'll do is we'll say, if in grading scheme 1, there is a 1 in the data, meaning the participant saw this grading scheme, that should stay. So we'll type in if there's a 1, then that should stay a 1, even if we transform the variable now. And now, crucially, what's very convenient here is that we see whenever there's a missing value, we know, based on the other variable, that they actually saw scheme B. So what we could do is we tick if the data in scheme 1 has a missing value, then we know it's scheme B, and we're going to say that's a 2 in this case. And if we then hit continue and OK, you can see that the variable has been transformed in itself. We still have the 1s that were previously there, but now instead of the missing values, it's added a 2, which represents grading scheme B. And what this allows us to do is actually to, well, I could, if it would allow me, yes, to delete this variable because we no longer need it. We know integrated into one variable whether a participant saw grading scheme A or B. Again, we should go to the variable view, perhaps give the variable a different name. We could just call it now grading scheme. And we could specify in the values that 1 was A and 2 was B. That's it for the data handling in SPSS.